All right, now we're moving on to what's called Shannon's expansion. In your textbook, it also goes under the term of decomposition for the switching of functions. So what is this? Well, all we're really trying to do is break a function into its parts. So let's take, for example, we have a function has three variables, a, b, and c. And what we want to try to do is divide it out into two parts by a. Well, to kind of divide it by two parts with a, we're going to do that. I take this a bar, and I'm going to have an a, and then I'm dividing up the function a little bit. So I'm going to say, what would that function be if I substitute a 0 in for the a on the first part? And what would that function be if I substitute a 1 in for the first part? And what we're really trying to get down to is this final statement that says, I have an a bar of some function called f0, or with an a of some function called f1. And we get to pick any of the three letters we wanted to do it. So if we wanted to divide by b, I take b, I figure out a b bar, figure out what that uh, expression would be with a 0. I do it with a b, what it would be with a 1. And then we get a b bar f0 and a b f1. So let's figure out how to do this. So let's say we have this expression right here. Okay, in this expression, let's say we're going to divide it. And let's divide by a. So I'm going to divide it by a. I look and I see, okay, here's where I have an a bar. And on this side, these are the parts that have an a with it. So really, that's part of the dividing that's already happening. This is where I'm dividing the two parts. Where I'm going to focus on, okay, here's where I'm going to figure out what an f0 is. And on this part, this is where I'm going to figure out where an f1 is. So I stays as a bar b plus, and then how I'm going to get f1 is I'm going to factor out the a. So I get a ended with c or b bar. And then the b, that's my f0. And then the c or b bar, that is my f1. So that's how we do the dividing up, and it's called the Shannon's expansion. Well, we could do the same thing with a Kmap. So how about we do it if I don't want to do the Boolean algebra? I just want to do the Kmap. Okay, so here's the same function. And what I'm going to do is, let's just fill in the Kmap first. All right, so the first thing we see is an a bar b. So let me just show you how to fill in the Kmap. So let's say this is a bar b in blue here. So I'm looking where a is a 0, because that would be the a bar. And then I'm going to look where b is set up. So those two areas, those two rows at the bottom are where b is a 1. And where they intersect, the intersection is where the 1s will go. All right, then let's do the next one of a and c. So I'm looking looking for where it's a 1. I'm looking for where c is a 1. Intersections. And then last, I have a b bar. Here's a, looking for where b is a 0. Intersections, well, we already have it. So I just need to fill in one extra spot. All right, so then we have the Kmap, and now I wanted to do the dividing by a. Okay, so let's say we're going to divide by a. When I divide by a, I need to find an a bar with an f0 and an a with an f1. So on the Kmap, what I'm going to do is I'm going to divide this Kmap right down the middle. Why am I dividing it down the middle? Because I have the part where a is 0, and then I have the part where a is a 1. Every part where a is a 0, that's going to form up my f0 function, and the a1 is going to form up my f1 function. Now, once I divided it, I have factored out a. I'm going to erase that piece. And now I have it as like two Kmaps. I'm going to have it as two Kmaps. So I'm going to solve it. Like if you want to, you can kind of view it as being a Kmap with two variables for F0 and then two variables for F1. So it will look something like this. And we have nothing on the top because the top part has been removed. So I got to solve it. I got a pair here for F0. What is that pair? Well, A is gone, so I'm not looking at the column anymore. I'm only looking at the rows, and we see that's a B. Then for the F1, I have a pair. Again, we're not going to look at the column. The column's gone now. So that gives me C. And then I got another pair that gives me B bar. So I can say, okay, this function now is A bar F0 is the same as AB. AF1 is the same as AC plus B bar. And if we just go back and verify, that's the same setup we had by doing it with Boolean algebra. Now we could use this as a way to solve a Boolean equation using a mux. So if I said, okay, I have a 2-to-1 mux, what am I doing? I'm going to say the selection is the A. So that's going to give me an A bar piece and an A, because this mux, if I choose 0, I choose the top line. If I choose 1, I choose the bottom line. And then what's going in there is F0 or F1, because that would be A bar F0 and A of an F1. So what is this F0? This F0 would be B, and the other one is C plus the B bar. All right, let's say we wanted to divide it a different way. Let's say we want to divide it using B. So if I wanted to divide it using B, I want a B bar F0 plus a B F1. How am I going to do that? Well, I'm choosing B, so I'm going to divide this Kmap in half. Why am I dividing it in half horizontally instead of vertically? Because I'm looking at the letter B, and I have two parts where there's a 0, and then I have two parts where it's a 1. And what did I do last time is I divided it, so I'm pulling out that one function. I'm erasing that piece. So then I know the top piece is going to be F0, the bottom piece is going to be F1. Let's solve. Well, I have nothing that's a group that I can pair up. So what is this green term? Well, it's in the A1 column, so it's A. And then it's on the row. The row doesn't have B anymore. It just has C. So it's A, C bar. Then I do the next term. That's A bar with C. We go down, and then we get A bar with C. So here it's a 1. So that's why C is why it's C. And then the last one will be or A, C bar. And if I wanted to put it into that mux, well, the mux has B as the selection. The top part is the F0, the bottom part's the F1, so the top part will be getting this piece, the bottom part getting that equation. And that's how I could do it as a 2-to-1 mux. And we could pick any letter. So let's do C now. C would be C bar F0 and a C F1. So now we're going to have to kind of divide it up a little bit different. I'm identifying C. So I find out where C's are zeros. I need to divide those two pieces out. So that's kind of going to split our Kmap into two sections. The top section is still my F0. The bottom one is still my F1. And then I'm erasing the C. Now this looks a little funny because you kind of have to, it's not an even half. Now you got to look at the middle section as being its own Kmap, and then you got to look at the sides, the top and the bottom, as being that they loop around. So if you wanted to do this, you can, say I'm just going to take the middle section, and that's the Kmap that looks like this. And then how do I do the F0 section? Is the F0 section, these two parts come together. So it's going to look kind of like that. Okay, so it's still a Kmap. So let's solve this. I got a pair for F1, and that pair of F1 is A bar because we're on the A0 column. And then B is gone. We use both pieces. For the F0, it loops around, over here would be together. Well, what is that? That's the A term. All right, so that's, the idea of what we're going to do it. Now, we did 3 variables. What happens if we do 4 variables? We just take the same concept and apply it across. So here I'm saying I want to divide by AB. Where's the AB? AB is the column. What is this going to look like when I expand? Is I'll have an A bar, B bar with an F00, plus an A bar B with an F01, plus an A B bar with an F10, plus an AB with an F11. So where are these dividing pieces? I'm going to need 4 dividing pieces. Here, I'm going to take every single column. And when I do these columns, I'm taking out AB, let me cross out all those pieces. And it's F11, F10, F01, F00. So those are our 4 functions. We're just going to solve them. And if we wanted to, we can say, okay, put that into a 4-to-1 mux. My selections are AB. I'm going to have 4 lines coming through. F00, F01, F10, F11. So let's do 00. 00 is a single term, a single item on its own. That's CD. Okay, let's do the next one. The next one takes up the entire column. So that means everything's a 1. So 01 is a 1. The 101 is a single term. Now we got to remember dropping down to 101. That's C bar D bar. And then the last one is I don't need to worry about the don't care. I just got a pair right there, and that would be C. And that's how, we set up that we're going to divide. Okay, let's take that and let's do something a little bit different. Let's say, how do I do it if it's AC? So they're not connected together. Okay, so here's A and here's C. I'm looking for when A is a 0, 0. I'm looking for where C is a 0, 0. Once I find that items, it's the intersection that matters. The intersection is, it's that quadrant. If I was to go down to the next quadrant over, it's 1, 1, 0, 0. I'm going to divide it. So this first piece is my F00. The one next to it is my F10. It keeps dividing. So the bottom left is 0 and a 1. So let me put that in black here. So that's F01. And then the piece that we have left is F11. A comes out. C comes out. So I have a 2 variable Kmap still. All right, now I just got to solve these pieces. So again, if we put it as a mux, this is going to be AC. And I'm going to get 4 pieces, F00, F01, F10, and F11. All right, so let's solve these. Let's start with 0, 0. I got a pair here. I use both rows, so D's out. I'm left up with B. Let's go down to 0, 1. 0, 1, I don't need to worry about the don't care. I have a pair here. I use both columns, so B is out. So I'm left with just D. Let's do 1, 0, 1, 0, single term. The X I can use the don't care. So that is B, because B is a 1, and then D is a 0, so that's D bar. And then last, I have a pair here. That would give me, I use both rows, so the D is out, so I'm left with just B bar. And I can do this process for any combination of letters that I wanted to do. So let's do one last one. Let's do BC. So we're going to do BC. Those are my inputs to this mux. B and a C. Again, I need to create a 0, 0, a 0, 1, a 1, 0, and a 1, 1. Okay, so where are these items going to be located? B, C. C, we know it's 0, 0, and then 1, 1. We know it gets divided. So if we want to divide, go ahead and divide that. That's where C gets divided. We divided C. Let's pull C out. We don't need it anymore. Now let's examine B. B is 0, 0 on the two sides. If it's 0, 0 on the two sides, then that's where we're dividing. So the whole middle section, and we can cross out B. B can get crossed out. We don't need B anymore. So let's figure out where each of these terms are. The middle section, let me just highlight it here and I'll erase the highlight later. This section right here, what F is that? It's F, we're doing BC, so we look at B. B was a 1, C was a 0. So that section right there is 1, 0. If we go down to the section right below it, what section is that? Well, we know B is a 1, and then we look at C. I probably crossed them out too difficult there, but we see it's a 1, 1. So that's where I'm going to get 1, 1. Then we have two items that are going to be F0s. So this piece connects with this piece. And what does that give me? That gives me my F0, 0. And that means the last one's F01. All right, so let's solve these items. Okay, so let's look at F00. I'll put this in blue here. So F00, it's those 4 boxes. We got to say, okay, what term is it going to be? I have a don't care here. I have a, let me just put in 0, 0, 0. I have a don't care. Well, the best thing for me to do is put that don't care as a 0 because I don't need to put it as a 1. If I put it as a 1, I have a term. I'd rather have a 0 or a 1 instead of a term. All right, let's do the next one. Let's do 0, 1. So here I'm going to put that in 0, 1. So those are the 4 terms that we have. Well, with those 4 terms, I got a pair vertically. That vertical pair is, I look at the column. I'm in the column of A with a 1. And I use both rows. So if I use both rows, there is no other letter that would be part of it. Then I got to do the wraparound, and I'll do that wrap in purple here. Well, I use both columns. The A is gone, so I'm left with just a D. Then let's do here in purple this F10. F10 is the 4 in the center of the top half. Well, how do I group that? I have 2 groups here. So I had this green group. I use both rows, so the D's out, and I'm left with a bar. And then I'm going to use, let's see if this pink shows up. I'm going to use both columns, so I'm going to be left with just the D, which is a D of 0. So that's the D bar. And then the last thing that I have left is the bottom 4. I have a pair there. I use both rows, so D's out, and I'm left with a bar. All right, so that's the way we do the Shannon's expansion, is really just trying to divide up our equations into different pieces. I showed here an example using the mux as a way to say, okay, why would I want to do this? There's other ways, other uses that we can kind of do, Shannon's expansion if we're trying to deal with larger circuits. It's a good idea to get some familiarity with it, and the mux it's a good example for us. The last thing I want to discuss here is sometimes you're going to have this mux, and with this mux, you might want to work in the opposite direction. So let's say all of it's already been developed for us. And let's say here it is developed as we have our F. Let's say it's an X and a Y. And then let's say we have a 0, we have a 1. Let's say we have an A plus a B, and then we have a B bar. And the question I want to ask you is, what is this F? What is the final equation that we're going to have? Okay, so this will give us an F00, an F01, an F10, and an F11. So with this items, I know my final F is made up of these pieces that are somehow connected together. And I need to know what is the missing term. Well, the missing terms are the combinations of the X and the Y. So how do I get a 0, 0 for XY? That's X bar, Y bar. The next one is 0, 1. That's an X bar and Y. And then I have a 1, 0, so that's an X and a Y bar. And then I have a 1, 1, so that's X and a Y. Then we can just substitute in, what do we know each of these equations of F0, 0, 0, 0, 1, 1, 0, and 1, 1. What did they form up? So let's substitute back into them. F0, 0 was a 0, so I got X bar, Y bar, and it was a 0. X, Y ended with a 1, plus X, Y bar ended with A or B, and then X and a Y ended with a V bar. Then we can do some cleanup. So let's just clean it up. Anything ended with a 0 is a 0. Anything ended with a 1 is the same item. And then if we wanted to do one last cleanup, the last cleanup would be a 0 I could just take out. So that would be what that final equation will look like.